morning all of you. I am Tanushri Dalai from Civil Engineering branch. So in the last class we solved a problem up to FW, that is LW into KS into FU divided by root 3 into 1.25, and today we solve rest of the problem. So after you calculate the FW part, by which you can get 1325.596 LW, then according to the question, your strength of the smaller plate is equal to the strength of the welding. So we have the value of strength of the smaller plate, which is 340.909, and the strength of the weld we got 1325.596 LW. So if we equate these two strengths, then we can get the value of LW. Okay. So let's come to the step 4, in which we have to calculate the length of the weld as LW. So for that, we have to equate strength of the small plate equal to strength of the weld. So strength of the small plate is 340.90. So we have to convert it into Newton, because 340.90 is in kilonewton. So we have to multiply 10 to the power 3 for converting it into Newton. Then equal to strength of the weld, which is 1325.596 LW. So from this we have calculated the value of LW, which is 340.90 multiplied by 10 to the power 3 divided by 1325.59, that is 257.16 mm, which is the value of effective length of the weld. Okay. So now you can see the effective length of the weld. That means, you see in the figure, the effective length means the length of the welding provided to merge the two plates. That means the lower plate, which is bigger in size, and the upper plate, which is smaller in size. And the welding is provided here in the sidewise. That means here and here also. And the sum of the two side welding is your value of LW, which is effective length of the weld. So the value we got from this calculation, which is 257.16, this is actually the sum of the two sides welding length. Okay. Then one side welding equal to LW by 2, right? If the sum of the two welding part is 257.16, then one side welding should be LW by 2, which is 257.16 divided by 2, which is 128.58 mm. So in the each side of the welding of the plate, the value is 128.58 mm. Okay. But while we provide the welding in the sidewise, then we have to provide this portion as welding and this portion as welding to provide the safety to this part of the welding. Okay. And this part, the smaller part in the vertical wise welding, is known as your end returns. According to code, your end return should be 2S. That means 2 into size of the weld. Okay. The end return should be twice of the size of the weld. So for the two side welding, we have to put two numbers of end returns. So in case of sidewise welding, we provide the total welding. That means the total length of the welding is the effective length of the weld plus one end returns, which is 2s, plus another end returns, which is 2s. So just put the values. Your LW value we got 257.16 plus 2s means 2 into size of the weld which we provide is 10. Again 2 into 10. Then your total value of the welding length is 297.168 mm. So in this way, we can get the value of size of the weld and effective length of the weld. So this is one criteria, or you can say this is the case number 1. Then we move to case number 2. So this is all about, in case number 1, this is all about the fillet welding case, in which you have to calculate the size of the weld and the effective length of the weld. So now comes to the case number 2, in which you have to calculate the strength of the weld in case of butt welding. Okay. So in case of butt welding, in general, we provide V-butt welding, which is two types. One is single V, another is double V. So in case of single V, it is a case of incomplete penetration welding. That means in case of single V, I told you in the previous class, the V-shaped welding is provided at the one side of the plate section. Either it may be in the bottom side or in the top side. Okay. And another is your double V-butt weld, in which it is a case of complete penetration welding. That is, the provision of the V-shaped weld connection is at the bottom side also and as well as in the top side also. Okay. So according to these two types of welding, the value of throat thickness is different. So while we consider the single V-butt weld, that means the case of incomplete penetration welding, at that case, the thickness or the throat thickness of the welding we considered as 5/8 of the thickness of the thinner plate. Okay. And when we consider the double V-butt weld, which is a case of complete penetration welding, then at that time we take the throat thickness as the thickness of the thinner plate. Okay. There is two plates are there to which we have to give the welding connection. From these two plates, which thickness is smaller, we will take that value as the throat thickness. Okay. After that, we have to calculate the strength of the weld as FW equal to LW into TE into Fy divided by gamma MW. Okay. LW is given in the question. You just only find out the value of TE, which is throat thickness, and Fy also given in the question. Gamma MW you have to consider whether it is soap welding or field welding, and after that you can calculate the strength of the weld. So now we will solve a problem regarding on butt welding. So here is a problem in which two plates of size 200 into 10 mm and 200 into 8 mm are connected by weld groove having, first one is your single V groove weld butt joint and second one is your double V groove weld joint. So your butt weld is also known as groove weld, don't be confused. Butt weld means your groove weld. Okay. So determine the maximum tension which the joint can resist The steel plates are of grade Fe410 grade with yield strength of 250 MPa. Assume shop welding. So here the size of the plate is given. This is your first plate and this is your second plate. And two cases are there. First one is single V groove weld and second one is double V groove weld. Then grade of the steel is given, which is Fe410, and yield strength of the steel also given, which is 250 MPa. And here type of welding also given, which is shop welding. So now comes to the solution part. Here you can see, in case of single V groove weld, as I told you in before, it is a case of incomplete penetration. You can see in this figure, this plate is the first plate, which is 200 into 8 mm, and this plate is second plate, which is 200 into 10 mm. Because the thickness of this two plate is uneven, so that in the bigger plate we have to give a slope and cut this part to equal the thickness of these two plates for the suitability of the welding connection. So you can see this upper part is given by single V butt weld or single V groove weld. So here you have to find out the throat thickness, which is 5/8 of the thickness of thinner plate. So the thickness of the thinner plate is 8 mm. Okay. Then 5 by 8 into 8, which is 5 mm. So your thickness of the throat is 5 mm. Okay. Thickness of the throat means this point to this point. Okay, that means thickness of the weld is known as your throat thickness of the weld. Then the effective length of the weld or LW, that is width of the plate. That means in which you will provide the weld, that width is known as your effective thickness or effective length of the weld in case of butt weld. Okay. So the width of the plate is given as 200. Okay. So that is the value of effective length of the weld. So now we have to calculate the strength of the weld, which is FW equal to LW into TE into FU divided by gamma MW. So LW we have the value 200, TE we have the value 5 mm, and FU is given as 410, and gamma MW for shop welding is 1.25, by which we get the value 200 kilonewton. Okay. So this is all about the single V groove weld. So now comes to double V groove weld. So here you can see, in case of double V groove weld, it is the case of complete penetration. So here the throat thickness is equal to thickness of the thinner plate only. So between two plates, the thickness of the thinner plate is this plate. So the thickness of the throat should be 8 mm, which is the thickness of the thinner plate. After that, FW equal to LW TE FY divided by gamma MW. So LW is similar to the single V groove weld, which is 200. Then TE is calculated as 8 and FY is given in the question as 250, and gamma MW for the shop welding is given as 1.25 from the table number 5 in the code book. So after calculating all these things, you can get the value 320 kilonewton. Okay. So in this way, you have to calculate the strength of the plate in case of butt weld. So today this much. We will discuss another case, which is case 3, which is the last case of the butt weld case. So today this much. Thank you.